Have you ever wondered how jet engines work? From supersonic fighter jets to commercial airliners, air-breathing propulsion plays a crucial role in aviation.
Today, we will explore two major types of jet engines, the turbojet and the turbofan. We will break down their working principles, advantages, and key differences.
Now we will study turbojet engines. The turbojet engine is the simplest type of gas turbine engine. It consists of four main stages: intake, compression, combustion, and the exhaust. Let's take a closer look at how it works. Air enters the engine at high speed. A compressor squeezes the air, increasing its pressure and temperature. The compressed air is mixed with fuel and ignited, producing hot gases. The expanding gases passes through a turbine which drives the compressor and then shoot out at high velocity, creating the thrust. Turbojets are powerful and can reach supersonic speeds. However, they are not fuel efficient. That makes them ideal for fighter jets but not commercial planes.
Hello everyone, we will discuss about a turbofan engine. A turbofan engine is the most widely used type of jet engine in commercial and military aviation today. It is an advanced version of the turbojet designed to be more fuel efficient, quieter, and capable of producing more thrust at lower speeds. It works on the Brayton cycle like the turbojet, but introduces a key difference: a large fan at a front that helps generate extra thrust by bypassing some air around the engine core. Now let us discuss about the basic components of a turbofan engine. It consists of 6 major sections and each playing a crucial role. First one is fan, that is bypass fan. The fan is the most recognizable part of a turbofan engine. It is a large multi-blade low pressure compressor stage that sucks in huge amounts of air. This air splits into two streams: bypass air and core air. What is bypass air? A large portion of the air flows around the engine core and directly contributes to thrust, that is called bypass air. Core air, the remaining portion enters the core and goes through the compression, combustion and turbine stages just like in a turbojet, that is called core air. Now going to bypass ratio, that is the bypass ratio is the ratio of bypass air to core air. High bpr, so high bpr found in commercial jets, that is example Boeing 747. These are more efficient, less noisy, better for long distance flights. Low bpr, that is military jets, example F-22 Raptor. This is more power, better acceleration, but consumes more fuel. Let us discuss about compressor. The compressor increases the pressure and temperature of the incoming core air made of multiple axial or centrifugal compressor stages. It raises air pressure 10 to 40 times. Higher compression leads to better efficiency and fuel economy compared to a turbojet. Next one is combustion chamber. Combustion chamber process ensures steady power output. The combustion temperature reaches 1500 to 2000 degrees Celsius, requiring cooling mechanisms to protect components. Here, unlike turbojets, turbofans burn fuel more efficiently due to their bypass airflow cooling effect. Fourth one is turbine. The turbine extracts energy from the high temperature gases. It is directly connected to the fan and compressor via shafts, making it responsible for driving the fan. It consumes in a turbofan, the fan consumes a significant portion of the turbine's energy. Driving the compressor, it compressing the air requires power. The turbine has a multiple stages including high pressure and low pressure turbines. Now let us discuss about exhaust nozzle. The exhaust nozzle controls the exit velocity of gases and contributes to thrust production. Unlike turbojets, the exhaust gases in turbofans are slower, making them quieter and more fuel efficient. In afterburning turbofans, extra fuel is injected into the exhaust to generate high-speed thrust for supersonic flight. Next we will discuss about bypass airflow. In a turbojet, all air goes through the combustion chamber. In a turbofan, a significant portion of the air bypasses the engine core, producing additional thrust without extra fuel burn. This makes turbofans much more fuel efficient and quicker than turbojets. Then the working cycle of the turbofan. Like the turbojet, the turbofan follows the Brayton cycle consisting of air intake, compression, combustion, exhaust. To all summarize this, we can say that turbofan engines dominate modern aviation thanks to their fuel efficiency, high thrust at low speeds, and reduced noise levels. While turbojets are still used for supersonic speeds, turbofan strikes the perfect balance between power efficiency and comfort, making them the engine of choice for commercial and military aircraft alike.
So, turbojet and turbofan engines both are the jet engines, but they have distinct characteristics that makes them suitable for different aircrafts.
Right. One thing they have in common is that both use gas turbines to generate thrust. The core working principle is air intake, compression, combustion, and exhaust is the same.
Exactly, and both engines are commonly used in aviation, just in different ways. Turbojets are preferred for high-speed application, while the turbofans are designed for efficiency and quieter operation.
That's one of the major differences, speed versus efficiency. Turbojets are great for supersonic speeds, which is why they are used in fighter jets and missiles, whereas turbofans work better at subsonic speeds, making them ideal for commercial airliners and transport aircraft.
Another key difference is the bypass ratio. Turbojets don't have bypass airflow. All the air goes through the engine core. Turbofans, on the other hand, have a fan that directs the large portion of the air around the core, making them more fuel efficient.
And that's why turbofans are quieter. Since more air bypass the combustion chamber, they produce less noise compared to the loud, high-speed exhaust of turbojets.
Good point. But because turbojets have higher exhaust velocity, they generate more jet thrust, which makes them better suited for military and high-speed applications.
So, in summary, turbojets are all about speed and power, while turbofans focus on fuel efficiency, range, and lower noise levels.
That's it. Same fundamental technology but different priorities in design and application.
And that's why aircraft manufacturers choose one over the other based on the mission requirements.
Absolutely. That wraps up our discussion on turbojet and turbofan engines. Thank you.
Thank you.